Welcome to Unit 1, Introduction to Programming, Current Trend and Future Trend. Today, we will learn 4 subtopics. Introduction to Programming Language. Let's begin. Students should be able to explain the programming fundamental and the unique feature.
We will learn about programming. We will learn what programming is. We will learn why it is important today. We will also learn why it is important in the future. Programming is not only for computer experts. It is a skill for solving problems, a skill for thinking logically, a skill for the digital world. In this lesson, we will study 4 main topics. First, programming languages. We will learn what they are and why we use them. Second, programming trends. We will see what is popular today and what may be important in the future. Third, data structures. We will learn why data organization matters. Finally, low-level and high-level languages. We will compare them and understand their differences.
Our lesson today is the next subtopic, Trends in Programming Languages. Today, we will explore the current and future trends of programming languages and their applications in modern technology.
What is a program? A program is a set of instructions. These instructions are given to a computer. The computer follows them exactly, one step at a time. A program is like a recipe. A recipe tells you how to cook. A program tells a computer how to solve a problem. Basic parts of a program. Every program has 3 main parts. The first part is input. Input is the data we give to the computer. The second part is process. Process is how the computer works on the data, step by step. The third part is output. Output is the result. It may appear on the screen or be saved in a file. Programming languages, computers do not understand human language. Programming languages help humans communicate with computers. They act as a bridge. Some examples are C, C++, Java, Python, and PHP. Each language has rules. Each language has different uses. Syntax in programming. Syntax means rules. Rules for writing programs. Each programming language has its own syntax. It is like grammar in English. If the syntax is wrong, the program will not run. This causes errors. Correct syntax is very important. First generation language, 1GL. First generation language is called machine language. It uses only zeros and ones. This language is understood directly by the computer. No translation is needed. It is very fast, but it is very difficult for humans. Pros and cons of 1GL. The advantage of first generation language is speed. It runs directly on the hardware. The disadvantages are many. It is hard to read, hard to write, hard to fix errors, and machine dependent. Second generation language, 2GL. Second generation language is assembly language. It uses symbols instead of only zeros and ones. This makes it easier for humans to read, but the computer still cannot understand it directly. It must be converted to machine language. Example of 1GL and 2GL. This slide shows 2 examples. One example is machine language. The other example is assembly language. Machine language looks like numbers. Assembly language uses words and symbols. Assembly language is easier for humans to understand. Third generation language, 3GL. Third generation languages are high-level languages. Examples include C, Java, and Pascal. These languages are easier to read and write. They are machine independent. They need a compiler or interpreter. Fourth generation language, 4GL. Fourth generation languages are closer to human language. They use fewer lines of code. They are often used in databases and web systems. Examples include Python, PHP, and SQL. Fifth generation language, 5GL. Fifth generation languages focus on problem solving. They are often used in artificial intelligence. The programmer describes the problem. The computer finds the solution. Examples include Prolog and Mercury. Language translators. Most programming languages need translation. They must be changed into machine language. This is done using translators. Only machine language does not need translation. Types of translators. There are 3 main types of translators: assembler, compiler, and interpreter. Each one works differently, each one has a specific purpose. Programming paradigms. Programming paradigms are styles of programming. Procedural programming uses steps. Object-oriented programming uses objects. Functional programming uses functions. Scripting is used for automation. Logic programming focuses on rules.
Our lesson today is the next subtopic, trends in programming languages. Today, we will explore the current and future trends of programming languages and their applications in modern technology.
Popular programming trends. Some programming languages are very popular today. Python is used in artificial intelligence and data science. Java is used in enterprise systems. JavaScript is used for web applications. C# is used in backend systems. Choosing a programming language. Programming language popularity can be measured. One example is the TOB index. It looks at job demand, courses, and search trends. This helps students choose what to learn. Job market trends. The job market needs programmers. Java is in demand. Python is in demand. JavaScript is in demand. C++ is also needed. Learning these languages increases job opportunities.
Our next subtopic is Introduction to Data Structure. Now, we will learn the basic concepts of data structures and understand how they help.
Data structures organize data. They decide how data is stored and how data is accessed. Good data structures make programs faster and more efficient. Why data structures matter? Data structures help solve complex problems. They improve performance, they reduce errors, they help programmers write better programs. Types of data structures. There are two main types of data structures: primitive data structures and non-primitive data structures. Each type has a different role. Primitive data types. Primitive data types store single values. Examples include integer, float, character, and pointer. They are the basic building blocks. Non-primitive data types. Non-primitive data types store multiple values. Examples include arrays, linked lists, stacks, queues, trees, and graphs. Stack data structure. A stack follows a simple rule: last in, first out. The last item added is the first removed, like a stack of plates. Queue data structure. A queue follows a different rule: first in, first out. The first item added is the first removed, like a line at a counter.
This is our final subtopic, low-level and high-level programming language. Now we will learn the differences, characteristics, and application of programming language types in computer programming.
Low-level versus high-level language. Low-level languages are close to machines. High-level languages are close to humans. Low-level languages are fast. High-level languages are easier to learn. Advantages of high-level languages. High-level languages are easy to read, easy to write. They save time. They are portable. They work on many systems. Programming errors. There are three main types of programming errors: syntax errors, runtime errors, logic errors. Understanding errors helps debugging. Control structures. Control structures control program flow. Sequential runs step by step. Conditional makes decisions. Iterative repeats actions. They control how programs behave. Memory basics. Computers store data as zeros and ones. The smallest unit is a bit. 8 bits make 1 byte. Memory stores all program data. Memory basics. Computers store data as zeros and ones. The smallest unit is a bit. 8 bits make 1 byte. Character storage. Characters are stored as numbers. ASCII is one standard. Unicode is another standard. Unicode supports many languages. This ensures correct text display. Memory stores all program data.